All right, looks a little better, some sort of weird bug. But now we're going to move on to talking about conjunctions. Conjunction is something that requires two propositions or two sentences, which is what I was trying to say at the end of the video. Like saying New York is the capital of New York and Austin is the capital of Texas. Each of those statements has a truth value, and the word and connects them together. So that means the whole sentence, including the and, also has a truth value. That's what conjunctions talk about here. So we have the and just conjunction. In a minute, we're going to have disjunction. So they both say junction. So the focus is a conjunction versus a disjunction. Con has an N like and the way this is written symbolically is like that. It looks like a up arrow, not quite the same as the caret symbol that's shift 6. This one is actually like on the line. It looks like an upside down capital V. A lot of times, though, we're just going to write the word out because we don't have to use symbolic logic here. It's just more to get the idea of we can determine the truth value of statements. Now, when there's more than one statement, the possibilities for the number of true, false, false, true, truth table pairings is larger. Before, there was only two choices. P could be true or P could be false. And the same is true here. P can be true or P can be false. But Q can also be true or false. So now I have two choices for P and two choices for Q. Now the rule that comes into play here, it's sometimes called the multiplication rule or property, or really a lot of times it's called the counting principle. But if I take the number of options for each thing and multiply them, that's my total number of possibilities. So 2 options for P times 2 options for Q is going to be 4 total options. All right, so I know my truth table should have 4 rows. Now the question might be, okay, how do I fill them in? Now, the way we traditionally fill these in is whichever singular proposition is the last one, which will be the one on the right. You start just true, false, all the way down. Then you go to the column just to the left of it, and you're going to double up from the groupings before. So this was single true, single false. So now we're going to double. Double trues, double falses. Now take a look at what we had. 2 trues, a true and a false and a true, and 2 falses. Those are all the possible combinations. P is true can go with a true or a false. P is false can go with a true or a false. It's another way of thinking of it as what's called like a branching diagram. And when we get to counting and probabilities later, we're going to come back to this in more detail. But here it's always 2 choices. So every time we add another proposition, which we are going to do in a minute, there's a triple conjunction, we're going to double the number. So with just 1, I have 2 possibilities. With 2, there are 4 possibilities. So if I add in the third, the R proposition, the 4 I had times 2 gives me 8 total. But this whole start on the right and double up works. Now, when we're looking at the and, the conjunction, and when I say that with a sentence, the first thing and the second thing, that whole statement is only true if the first thing is true and the second thing is true. They both have to be true to consider the whole big statement or sentence true. So if I say the capital of Texas is Austin, that is true. And the capital of New York is New York, that is not true. New York City is not the capital of New York. It's Albany. So overall, what I've said is not true because part of it was not true. And I used the and connector. So that is how the rest of the truth table fills in. P and Q is only true if both P and Q are true. So it is true here, but if only one is true and the other is false, or they're both false, that makes it false. Now in like computer old school circuit diagramming, this actually like comes up in wiring. If the two leads going into a thing are on, then you get a signal out. If only one of them is on, you don't get a signal. If none of them are on, you don't get a signal. So that's an AND gate. So it's taking two inputs and computing something out of it. So way down on the nitty-gritty level, that is what all our computers are doing, is running through AND gates, OR gates, and a couple other logical circuits. But you build those in really complicated ways and you get to our programming today. But this logic is the basis behind a lot of computer programming. When you use AND in computer programming like this is the way it works. Just like in Google, if I type Christmas and tree, it will give me every web page that mentions Christmas and mentions tree. Not necessarily the two together as a phrase, though. You have to type a little differently to get that. You use the quotes for exact phrase. But the AND is functioning like this. It's the logical connector AND. So it's true only if P and Q are both true. Now, triple conjunction, when it's all the same connector, and, we don't have to consider the order. It all applies like together. But if there's ever an and an or, then we have some parentheses around it for the ordering. It is totally fine to sketch those in if it helps you think about it. So like you figure out what P and Q is, and then you figure out what that is with R. We're just going to kind of do it all at once because it's only true if they're all true. But let's talk about filling in the table. So, and actually I'm going to type because that's why I put it in this way. So R is our rightmost one. So R is just going to get true, false, true, false, true, false, true, false. 8 of them. And now we're going to go all the way up to the top of Q, and we double down. Instead of single true, now it's going to be true, true, false, false, true, true, false, false. I feel like I'm in a typing class. All right, now Q had 2 T's, so we're going to double down. 4 T's. True, 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 false, 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 false. And that's what your last column should look like. It's all the trues on top, all the falses on the bottom. I say last, the last one you're typing in, but it's actually your first column. Now you can mix up the order of those. So you could do true, false in the P column and then true, 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 false, 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 false in the R column. The only reason I would suggest going with it this way is because this is the traditional way it's set up. And what a lot of students just do is memorize what the last column is. And that last column is dependent on the front of it being set up in this way. Or you just remember the concept. Like true, only if they're both true. And all the inputs got to be on for it to come out. Which means this is the only true that we would get from this triple conjunction. Everybody else here is false. Yeah, I'm not writing that. All right. So here in the truth tables, the number of rows is always a power of 2. So it's 2 or 2 times 2 or 2 times 2 times 2 or 2 times 2 times 2 times 2. We're not going to do 4 propositions. The truth table is just ridiculous to type. Well, it's actually not ridiculous to type. It's ridiculous to write by hand, which is what I had to do back in the day. We got this giant packet of papers that we would fill out. I had that packet for a very long time. I'm 40. The packet's 30 freaking years old. All right, now that we all know how old I am. So the next connector is or. Now in English, or can actually have two different meanings. Typically when I say either or, that kind of phrase, you can either have one or the other. I don't mean you can have both. Like that's how that phrase is expected in English, what we understand it to mean. In logic, though, to not get confused, we had to pick one of the two because sometimes or can mean both is a possibility. Choose ketchup or mustard. I choose both. And from an inclusive perspective, that is a legitimate choice. You could have some ketchup, you could have some mustard, or you could have both ketchup and mustard. And that is true for choosing a condiment. So logic or is the inclusive or, which means it's true a lot of the time. So instead of saying, well, they do say it the first way, it's true if either or both propositions are true, or the way most people usually think about it is it's false only if both propositions are false. So it's kind of backwards of the conjunction. The conjunction, the and, had one true and three falses. This one is going to have three trues and one false. All right, so let's start with, oh, that's right, I can't type on this one. So use the pen. True, false, true, false, true, true, false, false. I had to write that every single time. Some people just memorize all these triples, and I was like, that's silly. I mean, you can, but there's a pattern to filling it out. Just follow the pattern. All right, so, or if one of them is true, then the or statement is considered true. So P is true, this is true. P is true, this is true. Q is true, so this is true. They're both false, there it is. There's the F. So going back to my capitals, Austin is the capital of Texas, or New York is the capital of New York. Well, Austin is the capital of Texas, so we're good. I said something true. It's overall true, even though one of the propositions is false. We would say the statement is true because one of them is true. In the circuits, this means as long as one of the leads going in is on, you get an on coming out. So it's just kind of a signal of, is there current? Yes. If there's no current at all, then you get nothing. All right, we're going to cut this one there, and then I'll do the next one because conditionals are a little bit longer.